In this video, I'm just going to give you a really quick talk through and walkthrough of this example, this max example that you see here on the screen. It's for enacting frequency modulation in which one oscillator, this cycle tilde object here, is used to continuously change the frequency of this cycle tilde object down here. This is example and this patch are described and provided at this URL shown on the screen here. So if you go to that URL, you'll be able to download the patch, and you'll also see a written description of what I'm about to show you now, which is that we are going to try and create a vibrato or a frequency modulation by using a continuously changing signal instead of a constant value to set the frequency of this cycle tilde object over here. I'm going to turn up the amplitude just a tiny bit so that you can hear it, and turn it on. And you can hear that it's a tone that is essentially at 440 hertz, but it seems to have a little bit of life in it because it's actually got a 6 times per second vibrato going on that's going up or down by approximately 13 hertz around this center frequency of 440 hertz. So the reason I've chosen those particular numbers, 6 hertz is roughly the rate of vibrato that a singer or a violinist might use, 6 times per second of the finger moving back and forth, or the vibrato into the diaphragm being enacted 6 times per second. Modulation depth, 13 hertz, is about 3% of 440 hertz, so that's roughly a equal tempered quarter tone, pretty darn close. It's going to sound like not a crazy wide vibrato, but a reasonably wide vibrato, and yet we're still going to have a very clearly focused center pitch of 440 hertz. Okay, so how do we actually do this in max? Well, this part you've already probably figured out. This is a sine oscillator in a sense, which we're going to call the carrier oscillator, the one that we're actually going to listen to. And we're setting it to a multiply object so that we can control its volume, and we've turned its volume down quite a bit from a full volume of 1. We're listening to it at about 1/10 that volume, let's say. So that would be about, what would that be, about 10 decibels less. Sorry, 20 decibels less than full volume. Okay, so that cycle tilde object, every single sample is going to get multiplied by 0.1 so that it's not going to be terribly loud. Normally, if we just wanted a constant tone of 440 hertz, we would send that number straight in here into the frequency inlet. However, in this case, we're going to take that number 440 and we're going to add it to something else. We're going to use it as a constant value, which is going to get added to this stuff over here. So this is a cycle tilde object that's going at 6 times per second. That's a sub-audio rate. It's going to sound more like a rhythm. And normally that would go from -1 to 1. But if we just modulate 440 hertz plus or minus 1 hertz, that would be barely detectable. Instead, I've decided to multiply the amplitude of this modulating oscillator by 13 so that it'll actually push this constant value of 440 up to as high as 453, down to as low as 427, and so on. So you'll get a quarter tone wide vibrato. Here it is again. And you see that if I slow down the rate of that vibrato, I'm basically just changing the frequency of the low frequency oscillator. You can make it something ridiculously low, like 1/8 of a hertz. Now it doesn't really even sound like vibrato anymore, it just sounds like this weirdly slowly gliding tone. Okay, so let's put it back to something more normal, like 6 hertz. Let's increase the depth of the vibrato up to maybe like about a semitone or so. Now, very often operatic singers will certainly warble as widely as this, or maybe even wider, but it sounds a little bit silly. If we take it even wider than that, like, well, I'm just going to slowly drag this number up, and you'll see it's going to get crazier and crazier. So now we're at 220 hertz wide vibrato, which means it's going as high as 660 hertz and as low as 220. It doesn't sound like anything human anymore. It sounds like something artificial, obviously, because it is. No instrument actually does this. But that can be useful. And what if we even want to take that modulation rate up higher, make it even crazier? I'm just making a faster and faster vibrato, but it's still this crazy width. Now it's even starting to get into the audio range, and now we just get a big mess of multiple frequencies. If I go up to some factor of 440, now it sounds like a buzz with a fundamental of 110 hertz, and that's because it's actually creating this kind of crazy audio rate modulation is creating frequency energy at 110 hertz, 220, 330, 440, 550, etc. It's creating a very rich tone, the fundamental frequency of which is 110. So it sounds like a constant tone now, not like a vibrato, but it's a very rich tone with many frequencies in it instead of being just a sinusoidal tone. Okay, and I'm going to also take it down to back to that ridiculously low rate of 1/8 of a hertz. And you can see now over the course of 8 seconds, it's doing a sinusoidal glissando up as high as 660 hertz there, and then back down to 220 hertz, and then back up. Wasn't that exciting?